Well, good morning, good afternoon, good evening to everyone. My name is Daryl Innes. I'm with OFS. I'm one of the hosts or moderators of today's webinar with Karen Liu, and Karen is at Nubis Communications. Today, I welcome you to the Optical Connections webinar. The title of today's webinar is Why We Need New Architectures and support systems. If you've been paying attention to all of the different announcements that we've sent out for this webinar, you've noticed that the description has changed a number of times, and that's in part because we've been wrestling, trying to find the optimal topic that would be of broad interest. And we settled on this one in part because there's been quite a number of changes that's happened in the world since the pandemic. Clearly, there's been a lot of descriptions and discussions about the strength of broadband to support industry, education, medical, remote work, and first responders. And while that focus has been there, we also know that it's the entire optical network that's played a significant role that has performed admirably throughout this stressful period. As such, the fiber-based network operators are facing increasing challenges to support additional requirements from issues like deeper penetration into rural areas, replacement of copper, as well as new threats. And so there are stresses from an architectural perspective, and there are stresses from support system perspectives. And we need to improve these, or these are critical to enable a more sophisticated optical designs and efficient operations to meet these needs. So today, what we're really talking about is how can we make fiber even better than what it is? And we have a number of examples where we're looking at network and operational changes that will impact network in the future. From a format perspective, Karen, why don't you discuss a bit about how we're going to walk through the next 2 hours?
Yes, so we have quite a packed schedule today for the next 2 hours. And so we've got speakers spanning architectural changes, from enabling architectural changes, which can improve the network from the bottom up, all the way through what the implications are for managing the network, operationally speaking, and perspectives from the deployment, and then to cap it off, we've got a perspective of how the world is going to be changing even faster going forward, and how to anticipate those challenges. So with 4 speakers covering really the range of the network from an intertwined but non-overlapping coverage areas, we're really looking at the whole impact as fiber goes into basically into a new phase of maturity. So what we're trying to do is we'll have each speaker speak for approximately 20 minutes, and then we'll have a few minutes for questions, and we'd like each speaker to answer questions specific to their talk. Please put your questions by typing into the Q&A at the bottom of the webinar screen, and we'll have time for a few questions, and that way, if we don't get to your question, the panelists will still receive that question, and it can be answered offline, provided we have your contact information, of course. And we do hope that we will nonetheless be able to highlight a few of the questions and have a quick wrap up at the end. So we will also be, as moderators, pointing out the linkages between the talks as we go. So again, please find the Q&A button at the bottom of your screen and make sure that you're typing questions in there. Any other logistical questions, or if you would like something else, you can use the chat button as well. Daryl?
Yeah, so one of the things we want to try to do is make this interactive. And so it's of course difficult on these virtual meetings. So we encourage you to type into the chat. You may hear Karen and I or the other participant also ask questions throughout. And so we're just trying to make this as interactive as possible. So to start, we have Glenn Wellbrook, who's the Director of Optical Transport Network Architecture. And Glenn is going to talk about rural broadband, the final chapter in FTTP. And so Glenn, without further ado, please, the floor is yours.
Well, thank you, Daryl. Let's share my screen here. All right, can you see that fine?
Yes.
Very good. So the first slide I've got here, as I say, I think this is the final chapter. And the way I put it that way, or reason I titled it, was because once you get fiber to the home, you know, it's done. It's a done deal. You can bet then as much bandwidth as you could possibly use to that location by upgrading the equipment, of course, over time, perhaps. Granted, we're going to try and avoid that, and I'll go into that a bit as well. But I wanted to start with something that may seem irrelevant or not necessarily directly related to rural, but I thought it got to that why question. We did this study about 5 years ago. We were trying to get millimeter wave deployed in downtown Boston, and you know, we had a look at it, and everybody was saying, "Oh, this is so daunting. It's impossible to do. How are we going to get millimeter wave?" You know, we took a very conservative view of, say, every 500 feet. You know, at the time, because when we did the study, we hadn't deployed any, and we were having a look at it. And you know, what if we had to do it every 500 foot? And we're saying, well, that's actually 640,000 square feet of fiber coverage. We can do that. And then we looked at hotspots, because that was one of the other questions, and came back and said, well, that's, you know, 160,000 square foot if you averaged it all out and everything to that nature. And you know, the boss says, well, that sounds like a pretty dense area. And we said, yeah, but if we go outside of Boston to one of the residential areas not far from downtown, we actually have Fios deployed, and not everybody takes it, but it goes in front of everybody's house on average every 10,000 square feet. So you can about imagine how dense that is compared to even millimeter wave or what folks say for public hotspot. Point being that we've got fiber in a lot of places already. We do it not only in Boston, but lots of other places in big cities, New York and DC and other very dense areas. So why does that matter? Well, welcome to rural. Here, you know, the official definition anyway from our government anyway in the US is 100 to 300 homes, depending which agency you're talking to and how much they're going to fund and what they offer on the various bids. But the actual locations vary a lot more than that. You know, I would argue that 100 to 300 homes per square mile isn't very rural, at least not where I'm from anyway. It can get a lot more rural than that. The geography also varies dramatically because, you know, unlike most cities where I won't say any two are the same, but a lot of the infrastructure is there. You know, it's put in place. It's you've got ducts, you've got right of way, you've got a lot of. It was built for things like telecom and other utilities to get to every household. In rural America, it's a bit different. Now, some things are better. You've got a lot more, I would say, freedom or ability to do different things. You've got less infrastructure. Along with that, you tear up less roads. You've got a lot more aerial than buried, but there are quite a few obstacles that you got to care for as well. That includes going sometimes the shortcut. The right of way doesn't always go down the road. Sometimes the road has a lot of trees and whatnot in it as well. And so it's different. And that's probably the gist of this. The services So I'm saying the punchline is it's not new, it's just different. And we want to make sure that we optimize for that differences. Now, one thing I wanted to add here is that every home that we go to in a rural area already has copper. It has had copper for a long time. We gave dial tone service for 100 years. It's not new at all. We're upgrading that to fiber though. Granted, again, I'm going to try and stress that nothing about this is impossible. It's just making the economics work, and how do you go about doing the best job there? Because from a technical point, yes, if we've got copper to a location, we can put fiber to a location, and we can offer a broadband service. So what are some of the options? So first one is splitters. Just something as simple as, where do I place my splitter, and how often do I put them, and where do I do them? For Fios, which is our fiber to the home service that goes in Boston, as I showed in the beginning, and other big cities, we use a centralized split. You go out to one location, you got a 1x32 splitter, you got a number of them in a fiber distribution hub, and then your F2s go to local residents, usually less than 2 kilometers. I mean, it's quite close. A distributed split says, well, I'm not going to reach, or I don't want my F2s to go that far all the way back to that one location. So I'm going to do a distributed. In other words, that fiber distribution hub, I'm putting a 1x4 or 1x8, and then I'm going to go further out into the field, albeit 2 kilometers away, 4, 6, 8, and I'm going to put the second set of splitters and just address the homes locally, as opposed to running all of those F2s all the way back. Again, it's a way to do it in a more economical way. And it uses 1x4s and 1x8s, as needed. You can even have 1x2s. There's all kinds of combinations, as you might imagine. All of this is still power split PON, nothing different, nothing that we would have active in the field yet at this point. It's just distributing them versus centralizing them, and it makes it a lot more economical. It also reduces the fiber count, or smaller cables are needed, because out here, especially where you're hanging these F2s, that can be a very small cable, if you will, and it can be done aerial. It can be done with P clamps. It can be done in a without overlasting or bearing or things of that nature. Again, making it lower cost and faster to deploy, because a lot of this is also plug and play. Keep in mind the centralized one, we bring out F1s, we do a fusion splice to all of those splitters, and then we got a ton of connectors inside of this box, or that fiber distribution hub. Here, a lot of the F1 to F2 or F2 back is connectorized, so it can be done almost, we kind of say by the installers, by the technician who's turning up service, as opposed to the construction folks that are going out and pre-positioning everything in place. So it makes it faster and lower cost. Another thing another tool in the toolbox, or thing that we can do, is have active equipment that is in the field. Generally, you would never see this in a large metro, because everything is home run back to the central office, and it's all within 20 kilometers or 30 kilometers reach. We don't have any active equipment in the field, because again, it's easier to maintain it and install it if it's all in the centralized location. But in a rural environment, we certainly have this option, and it's not new. We've had it before in rural environments. They were DSLAMs or other boxes that were out in remote terminals or remote central offices. Keep in mind that we've got wire centers. We call them wire centers, but a central office, small central office in every community. And we can use those to host either. Now we'll put all the heavy, the big iron, if you will, the BNG function and the OLT portion back here. The aggregation shelf goes to the transport. That's dual homed and everything of that nature back in a host CO, we're going to call it, but the largest CO in a given geographical area. And then you can extend, the PON shelf, just the small portion of it, as far as you want, really, with bidirectional 10 gig optics off the shelf. We use BiDies here. The main reason is that a lot of this fiber already exists, especially to a remote CO or even to a cabinet, because again, we had active equipment in a lot of those locations to begin with, certainly in the central office, but also in a lot of these remote terminals that were served with fiber before, and then copper left here. And we're saying, well, let's reuse that fiber. And then all we have to build is the distribution side of the fiber, again, making it significantly cheaper and faster to do, rather than trying to build brand new fiber runs and do F1s all the way from the host CO. You can do it from the remote CO and then just build out the distribution side, which is going to the customers and reducing that fiber count that goes all the way back to the OLT itself, or to the ag shelf and the BNG function, which is where you host all of the compute, if you will, that goes with PON. So again, nothing super impossible or technical to do, but reapplying or changing some of the rules that we have done before that we would never need in a Boston area, but we would need it in a rural environment. Now, one of the questions we've been asked is, well, then what are you going to use? We use GPON today. That most of you might know that we've started upgrading to NG-PON2. Why use that in a rural environment? Because that's, we're saying, well, if we're going to deploy brand new, it's greenfield from a fiber perspective. Now, if it is brownfield, it's got GPON there, we can grow that if we need to, because a lot of these remote COs they just didn't have it all the way out to the remote area. But if we're going in greenfield, we certainly use NG-PON2. How come? It's mostly this, well, all of these things, but all service types. So we can do residential, we can do cell towers. There are businesses out in rural, and we can capture all of that with one access technique. In other words, one method of doing it, one OLT to service all of those. We have multiple wavelengths in NG-PON2, so we can either add more capacity if we needed to down the road, or if we want to do things like service separation. If you wanted to put cell towers on a cell tower backhaul, this is Ethernet backhaul. It's not CPRI or front haul or anything constant bit rate. For those, we'd have to use the bypass fibers, we call them. But for cell sites or a large business out there or business park of some sorts, we can certainly put them on a separate wavelength if we would like to do that because of maintenance reasons or anything else. Higher speeds are available. That's wavelength bonding. That's the beauty of one of the reasons for NG-PON2 is that you can put wavelengths together. They're 10 gig each. You can bond, 2 or 3 or 4 of those together to get higher bit rates over time if needed. You can also run WDM over the top of that. There's an allocation, if you've seen the spectrum, where you can run just pure WDM over the top. There's also backward compatibility. Part of it was an industry standard, and I'm not saying that folks can't take XGS and put it over some existing other PONs, but NG-PON2 is guaranteed from a standards perspective to be backwards compatible with anything that we might have there, including a video broadcast. If we had it in at least in our deployments, we've got that. We got to care for it. But basically, it's a carrier grade access system designed for anything that we might run into or either current or in the future out in that rural environment, so that we don't have to go back and change it out later. And part of that changing out later is because it is really painful to go out to when you go from, say, BPON to GPON, you have to go to every single address and change that end customer equipment, where something like NG-PON2, arguably, if they don't ask for a change, we should never have to go back out there, because we can certainly go all the way to 10 gig. And if we wanted to go beyond that, then yes, we would go back out. We could bond wavelengths without changing the active equipment at all. So in summary, again, I only had 6 slides because I want to let the other folks talk as well. We want to optimize the PON architecture, and that's the passive optical network. That's the outside plant piece. That's the expensive stuff. We want to optimize it for the lowest cost. We can optimize the OLT architecture, which is the active equipment back in the central office, for the, to reduce the fiber count, for fiber savings. In other words, reuse what we can in the field, because again, a fiber's a fiber. We can put OLTs over just like we would have put the previous generation of a D-slam or something of that nature over the top of it. We need to employ new tools and procedures as needed, and that's things like, for the outside plant, that plug and play that I was talking about, connectorized distributed split, or long span with P-clamps and things of this nature, stuff that would make the construction quicker and easier and cheaper, because that's where the real cost is here, not necessarily in the active equipment itself. Bottom line here, rural is not new, and fiber's not new either. So my punchline is, we got this. We just gotta be diligent about how we go about it. Daryl, back to you.
Thank you, Glenn. That was fascinating. I'm really encouraged by this idea, and I guess you've got history, right? The copper that was out there has been good for 100 years, and it sounds like you've got that same vision that, now with NG-PON 2, you can put that out there just like the copper was, and layer new services on top. Copper was amazing, right? We got all the way to DSL, which was never envisioned, I'm sure. And it sounds like you've got something similar going. I'm just curious if you can tell us a little bit more about that. The largest CO in the area, that main active site now, how many homes would that be? I know you said there's no typical, but how many homes is that covering? And then, once you get out to the reusing the fiber that's already going to the remote sites, how old is that fiber, and what condition is it in, and what kind of support do you need to make sure that's still good?
Yeah, great question. So you're right, those central offices are vary all over the place, but usually a few thousand. It's a small community, if you will, a village, a town. The language varies a bit, but what you might consider a farming community, or a remote rural, because it's not as rural as one might envision, of course. There is usually a community where the school's at, and where the businesses are, and things of this nature, and that's where our wire center is. And then from there, of course, it does get out to, between those, it gets to be quite rural, and that's where, before active equipment was out in the field, and we can continue to leverage that fiber. As you say, it could be 20 years old, but it's still good stuff. It's a G.652. I'm not saying that there isn't some that has to be replaced, but keep in mind that a lot of that was done, not in the 80s or even the 90s. It was done later in life, when we had to grow to DSL and things of that nature. That far out into the field is when a lot of that fiber was put in place to support what was, sort of broadband at the time, but adding the capability to do DSL and those functions further out into the field, and that's when a lot of those remote terminals or RVs were put in place. So that fiber's, it's used, but it's not used up yet. It's not ancient, so we can reuse a lot of it. Now, I'm not saying that all of it's going to work or anything, but we'll try and leverage it when we can, and I think that's the critical piece is trying to take advantage of that, or if you can, and if you get that and you can save some cost and time, then that's the right thing to do.
Thank you.
Do you run into roadblocks, Glenn, as you start to plan these networks? I mean, there are a number of things, issues like local requirements, if you're trying to put in new fiber, to get permits and so forth, but even other issues internally, like, I thought the cable was here, but it's not there.
Every day. Yeah. Now, the good part here, Daryl, and a lot of it is aerial in these rural environments, especially as you get further from the wire center or the central office. And that's got one big advantage. You can see it up there. You can follow it, put a truck, but certainly stuff that you run into that is damaged or needs repair or needs replaced, or you can't necessarily locate it, not sure where everything went. That happens, of course, but keep in mind that a lot of this stuff is in use today, and there are businesses out there, usually around the city center, if you will, city being a loose term here, but that near the wire center, is usually fiber today. Usually we've got, active traffic there. We've got some fiber in place, perhaps not everywhere, of course, but we call it the donut. And then it's the outside pieces that are being, that were copper and need to be upgraded to fiber for broadband. But a lot of times that, near the wire center, the city center, if you will, had modern connectivity. And then it was the residential area outside of that's where the funding is approaching us. So that's where the government has issued funding and states and counties and things of this nature. And those are the ones that are targets. The underserved and not served is where they subsidize that piece of it. They do not do the inside piece where perhaps they already have coverage or have a broadband service available to them. And a lot of times that broadband service is us or somebody else. But it is usually in the town itself and not necessarily in the, in the connecting areas, the roads that go beyond that, the rural roads.
Mm-hmm. Yeah. It's just a big country, and there's just so many places to support.
Yes, it is a big country. It's and that's one thing that probably makes the U.S. a little bit unique in that respect, is that there's a lot of rural out there.
Right. I mean, even when Karen asked about the central offices, I was thinking, do you run into constraints in terms distance constraints, right? Because these places, they can be far from some of the end customers, and so
They certainly can be. And that's where that remote OLT comes in pretty handy, because then you're putting that PON shelf that, again, the BNG function and stuff that can be shared stays in that common location, but then you use, off the shelf extended reach BiDIs, so that you're down to one strand per PON shelf, of course. And that PON, then your PON distance only starts where that shelf is out. So, that puts you pretty deep into the network before you ever start your actual PON distance of 20 or 30 kilometers, depending what kind you've got.
And then things like network sharing, right? As you deploy this network, these aren't necessarily all your customers. Is that the way you think about this? And so sometimes you're sharing with another carrier, meaning they're purchasing, whether it's wavelengths or fiber or something like that, right? So that's part of
that. Yes, that's part of, and this is, keep in mind that there are a lot of cell towers out there, and there are a lot of, businesses that are in remote areas that also are quite, that need bandwidth as well, that are somewhat underserved, and we're hoping to capture that business as well. So not only the residential user, but also that, that remote business or cell towers or any other utilities, anybody that needs connectivity out there. We want to be able that we can support that with the infrastructure we put in place. And that's part of, again, NG-PON 2. And again, it does have those bypass wavelengths in the event that you had something really, 100 gig demand, if it ever came about, or something to that nature, or a constant bit rate, or something that you wanted to carry over the top of that existing, you're going to put in the fiber infrastructure. That's the expensive part. You want to make sure that you can care for any needs that are out there when you do it. Because it's pretty diverse. You'd be surprised the kind of demand you find out in rural America.
Yeah. And that's great, Glenn, because you've just nicely set us up for the next couple of talks, because Erik is going to be talking about how to get even more extended reach and extract efficiency out of the network to be able to reach everybody as efficiently as possible. And Johan's going to cover some of these aspects that are more sophisticated as far as the business of you've deployed the network, but it's not all your customers, and you've got to manage the more complicated relationships of services on top of that network. So
thank you very much, Glenn. That was very enlightening and very good. We're going to move to our next speaker, and so this is Erik Pennings. Erik is the business development director at Ensure, and Erik is going to talk about how to stretch limits of PON networks by deploying novel splitting architecture. So Erik, I turn it over to you.
Okay, well, thank you, Daryl and Karen. Let me share my screen here. The presentation. Okay, can you see my screen?
Yes.
Okay. So thank you for your introductions and thank you, Glenn, also as well. So not only was the presentation enlightening, but I think I could not have wished for somebody setting the stage better for what we wanted to bring. So that's really helpful. So indeed, it is connectivity to you and how to stretch limits of PON networks, and especially by deploying novel splitting structures. And there's actually 3 topics here in the slides that I'm presenting. So we're starting a bit with, what is actually bringing all of us together here. And the overall goal for all of us combined, at least we feel, is to create a more interconnected planet. We all need our internet. We need to be connected with social media to work, remotely, order online. But this all has changed to a good degree. Also, the pandemic kind of accelerated this. But this interconnectivity needs to be robust and dependable. If you're in a hotel and the Wi-Fi is not working, at least I try to go to a different hotel, but that's a total no-go. Then the second topic is a bit the role of integrated optics. So in terms of making this interconnected planet be more robust and more dependable, integrated optics can really help, but it can also help by allowing us to make asymmetric splitters, and in that way help to stretch the PON networks. And that's then the third topic. With PON going further and further, and especially in these rural areas, we may run into limits of fiber budgets, of lack of fiber. And the question is, how can we overcome these limits? And we think that the asymmetric splitters can really help here. So again, how did we get to here? The connectivity is driven by fiber, and not only the fiber, but also the integration. So it's electrical integration and also the optical integration, the optical chips. And these together have basically allowed for a kind of a revolution by bringing this interconnectivity to all of us, whether, at home, to the tower, or in the data center. But the last mile is still critical. So in the last mile, this is where, a lot of the cost is. The cost is really in the digging, the permits, even if you do it in the pole. And it dwarfs to a good degree also the equipment cost. And this is also where the reliability is critical. So in the metro and long haul, there's often redundancy. But in the last mile, there's a single fiber, and if an amplifier or a splitter or something else fails, then often the connection may get lost. That brings us to the question of how can we make this connectivity premium? And one of the things that helps enormously is the fact that it is passive, as compared to good old copper with a lot of amplifiers and so on. Those amplifiers could fail, and they also were, more expensive to maintain. But the passive fiber, the PON, really helped enormously. Then secondly, of course, fiber breakage can be a problem. This is maybe more so if it's aerial than if it's underground. I've experienced that partly myself in the US, where a lot of fibers are in the pole, and then if there's a storm or something, there can be interruptions. But the fourth thing is that, and that's a bit what we like to bring to the table here, is the use of premium components. In the past, the telephone network was really built for reliability, but cable TV and data were initially a bit different. If the TV would fail, then at least the kids could do their homework for a change. And if you got your email a day later, that was still doable. But today, this really needs to be up and running and be dependable. And that brings me to the question of how do you do quality? How do you make premium components that are really dependable? And I'd like to show you here an example of a Saab and a BMW car. I actually owned a Saab and a BMW secondhand, of course, because we're in optical. But it's just an example. Both cars are really high-end. The companies are both ISO 9000 certified and fully, crash tested and so on. But still, with the Saab, I may have had bad luck, but I was at the garage every other month or so, and it could be anything. But with the BMW, I called them after a year, and they said, "What are you calling for?" So the BMW car will only be serviced every 2 years. And that is indeed what happened. So even with ISO certification and even with full reliability testing, there can still be enormous differences. And the question is then, how do you do this quality, this dependable that we need so much in the access especially? And our vision on that is, to a good degree, on the left-hand side, it shows the products that we do. It is the splitters, the multiplexers. We make ferrules for connectors and jumpers, but we also have WDM multiplexers, EDFA modules, and modules for sensing. But our vision, our conclusion here is that beyond ISO 9000, beyond Telcordia, it requires a dedication to premium, to simply invest in the very best that you can make, and also in people and support. But the main thing is to be fully vertically integrated. If you buy a PLC chip from somebody else, it will be hard to really know for certain how reliable it is. But if you control the entire supply chain yourself, that's the best way to guarantee the quality and reliability. We'll show here a few examples. So this is a premium splitter. This was a customer that came to us that really had a requirement for ultra low losses. And we, in the end, we shipped to them a 1x4 splitter that only had an excess loss of 0.5 dB. And that was possible because we make the splitter ourselves. We also make the connectors, and by combining the very best connectors, grade A, together with a screened PLC chip, we were able to satisfy that requirement. But the other thing is, if you take the example of the cars, then the question would be, what should I have done, ideally before either buying the Saab or the BMW? If I wanted to know how dependable it is, because normally you only find out once you have the car. And the thing would have been to go to somebody else and ask them, a BMW owner or a Saab owner, and ask them for their experiences. And this also applies here for the components. It's customer referral. So this is something that one of our customers, Vodafone, has been saying. And their main reason for using Ensure components is the reliability and the dependability. And what applies for Vodafone is also true for Telefonica. So their qualification goes way beyond Telcordia GR1221. I won't go through all the details here, but in the end, we were able to meet that very well. And also here, the key is really our focus on quality and the complete vertical integration. And that applies also to, a lot of customers beyond these two that, we're serving worldwide. That brings us to kind of the second main topic in my presentation, that is from quality to integration. So why is photonic integration so critical? And if you look indeed at the fiber to the home architecture, then the fiber, apart from the breakage, should be dependable, but the other structure here is the splitter. And again, this is the PLC chip and the connector. If you control this and you do this all in-house, then that's the best solution for controlling the quality. But the photonic integration itself also helps in other ways. It's good to realize that we've had the electronic integration, which has been an enormous success because a lot of the technology that we use these days relies on electronic ICs. But the same is true now for photonic ICs. And the first technology here to really be commercialized was the PLC, the planar lightweight circuit. And that was actually for use in splitters in fiber to the home. And it basically means that you have a chip here with one waveguide in and then 4 waveguides out. This is for a 1x4 splitter, as you've seen in the previous example, with then the input fiber and the output fiber. And what's important to realize also here that something as commonplace as a PLC splitter can be bought from many places, but there's actually only a very small number of PLC fabs. Most of them are in Asia, and a lot of them are also focused on the data center, but there's very few that really focus on fiber to the home. Now, this is the reason why the integration is so important. So on the left-hand side, I guess many of you will, this is the text here. But you will remember this on the top left-hand here from the James Bond movies. This is a Cray supercomputer. It looks very impressive from the outside. But I actually happened to be at Cray one time where we had a meeting, and they also showed us the backside. The backside is actually, mind-boggling in the sense that there's lots and lots and lots of wires that actually interconnect all of these processors. Many of these were, initially hand soldered, and if something would happen with one of the wires, then the supercomputer would not work. And something similar happens right now in optical, where if you look at the data center, then everyone sees these beautiful pictures with all of the blinking lights, and everyone goes, oh. But if you look at the backside, then you have something similar where it's more or less a spaghetti of fibers. And if one of them breaks or it's not well connected, then you have basically the same issue. And here's where the integration comes in the sense that if you have a single 1x64 splitter chip that replaces 63 individual 1x2 splitters, so it enormously reduces the number of interconnects and thereby not only brings size reduction and cost reduction, but also improves enormously the reliability. And that then brings me to the third topic, that's the limits in PON networks that Glenn also talked about, especially if you go to rural. So with fiber to the home, which is really a great development and now reaching more and more people, the question is, we're running into limits. The limits can be fiber shortage. The digging is the most expensive part. The incumbents have fiber, but many newer carriers may be short of fiber. And leasing a fiber can be very, very expensive. And then also in rural areas, you may sometimes just not have the fiber, or it may not match the architecture that you had in mind. The link budget can also be an issue. Sometimes, the PON standard was designed for a particular number of connectors and splices and so on. But in some cases, you may have a fiber that is simply too long or too lossy, or there may be too many connectors. And what you see often these days is that with so many deployments going on, carriers lack sufficient technicians that can do the build outs, and therefore they rely increasingly on plug and play with connectors. That makes it a lot easier to do the installation, but the connectors can be lossy. And then Nokia kind of indicated to me that the address, of course, also with the 50 gig PON standardization efforts that are happening, at some point, an architecture that was designed initially for 2.5 or 10 gig, but now needs to be stretched to 25 or 50 gig, you're simply running out of power. And at some point you run out of the options here. And then because of backward compatibility, we also need coexistence elements. So then when we look at different PON architectures, one architecture that is used in some parts of the world is the point-to-point. That's, for example, the case in Nordic countries, Europe, and also in the Netherlands, where I am. So every home has its own fiber, it's future-proof, there's no sharing of the infrastructure. And but in terms of the total amount of fiber, this is, of course, the worst case. Now, the star architecture, which is used in PON, is to share the expensive transmitter in the central office, and to also share a lot of the initial fiber. But then ideally, if the splitter would be very close to the homes, then you could save a lot of fiber. But in practice, this close to never happens. And the worst case is actually if the splitter is close to the home, then you effectively are back to the point-to-point. You have a shared fiber, but the shared fiber may be only 1 mile, and the additional miles are all separate. So then you still have a lot of fibers. Now, what is getting increasingly more popular these days is what is called either the daisy chain architecture or the tap architecture. And this is ideal for rural. So if you are indeed, say, in areas in the US where there's way fewer people, then they will not all be concentrated in one place. You can go from one or a few users to another few users. And then the add drop architecture, where you have a single fiber, you drop to a number of homes, then you continue with the fiber, you drop to another number of homes, you continue, and you continue here until the end, is then a architecture that will save you a lot of fiber. In the best cases, it's pretty much one fiber with a few small drop sections. The last splitter will here be symmetric. And then if we go, so how do we do that? We will need for this a asymmetric PLC splitter. So again, this was the architecture as it was envisioned originally. And but that has one splitter, and then more or less imagine all the users to be at equal distances. But for the daisy chain architecture, which may be much more efficient in especially rural architectures, you need a through section and a drop section, and that can be done with an asymmetric chip, which has here an asymmetric splitter with most of the light passing on and a through port, and then some power is tapped and then split equally, in this case in 4 equal output ports. And the thing to realize here is that you will in practice need many different configurations. So if you look at this architecture, the first splitter ideally has a 95% through power. Then here it may be 90% and here 70%, but the last splitter should actually be passing a lot of the light, else there will be insufficient power for the last user. Yeah, so this is what you see here in this slide. So the you will, in practice, in order to make this happen, need many different variations, not only in the sense of the tap ratio, but then also in terms of the splitter ratio. So ideally, if you want to fully optimize this, and in practice, this may need to be done because you simply have no power to waste anymore, then you may need drops, the split ratios of 1/3, 1/5, 1/9, and 1/17 with different tap ratios. And ideally, this is all a single chip rather than combining a symmetric PLC splitter together with a a separate 1/2 splitter, because it introduces one extra splice and it will be bigger than what you can do with a single chip. Now, the second use case for this, say, asymmetric architecture is what you have in multi-dwelling units. So if you have a high-rise, then the traditional way to build this was to have a splitter in the basement and then essentially go up with, as many fibers as you are needing for, covering all these users. But that's not efficient because you will have way too many fibers going up. It's much wiser and it will save a lot of fibers if you have the splitters in the basement, and then, or at least one of them, and then you go up with one fiber. You have another splitter on the first floor, another splitter on the second floor, another splitter on the third floor. And this way, the number of fibers that is going up can be reduced enormously relative to putting all of the splitters in the basement. Now, this is what partly led us to develop these asymmetric splitters. It was done based on, a key customer that wanted us to develop this for them, and which we can do because we have the fab ourselves. But the interesting thing is that recently we've run across, a number of really interesting use cases. So there was one customer, a carrier, that wanted to connect 128 users with a single feeder fiber. So one fiber, but then 128 users rather than 64. Now, normally this is not doable because the PON architecture was not designed for 128 users. And this could be possible, for example, if this carrier did not have many fibers themselves. They were short of feeder fibers, so they tried to have one fiber and simply cover double the amount of homes. And if you would need to lease the fiber, then this could be very expensive. The trouble is, however, if you go from 64 users to 128, you will incur 3 dB extra losses. And what many cases then happens is that people deploy the shaving method. So in the end, you will try to take a little bit power here, you will take a little bit there, and you will specify splitters that have very low insertion losses. But there's a limit to how far you can go with Mother Nature. So those components are either not available, or even if you can find them, they're way too expensive. But that does not make sense because, say, all of the users here will actually have much too much power because the architecture was designed for 20 kilometers. So in this case, no matter what we did, we could make splitters and spec them at 23.3 to 23.9 dB. But again, by taking some of the power from users that are closer by and redistributing this to the users that are at the end, and there was only a slight amount of asymmetry that was needed. And in that case, we were able to get the furthest users to have 22.7 dB, which was exactly what the carrier needed. And the closest one still had 24.7 dB, which means that they still have a lot of extra power. The fourth use case was something that we recently experienced. So this was a carrier that were also short on power. And most likely it was an architecture which had a patchwork of fibers. There were too many splices, too many connectors, or they were connectors with, too much losses. And also here, the shaving simply did not help. And even if you could find them, they would be too expensive. But again, by distributing a little bit of power from the group that is closer by to the group that is further away. So here you see that in the symmetric architecture, no matter what we did, the insertion loss would not have been lower than 13.7 dB, which did not cut it because they had too many connectors. But by making it slightly asymmetric, now you see that for the further homes, there was indeed sufficient power, and we saved half a dB. And that goes at the expense of the ones that are closer by, but they still have too much power. So that takes me to the conclusions. So our vision is really connectivity to all, to create this interconnected planet. And premium is important here next to the size and cost. And we believe that the key to achieving that is vertical integration. And next to that, the photonic integration helps as well. But this integration also allows us to make custom PLC splitters. And that is the case for the asymmetric one. And once we had that, we quickly figured out that there's actually a number of very relevant use cases where carriers had problems in deployments, and the splitters were able to help them to overcome this problem. But what we did for them, we can of course also do for you. So that takes me to the end here.
Thank you, Erik. Are there any questions coming from the audience? And
yeah, I actually don't see any questions coming from the audience, so I'd like to encourage again that the audience, the participants, as you're labeled in the Zoom, and we mean that wholeheartedly, you are participants, so please enter your questions in the Q&A or chat below. But I actually do have a question. I noted, Erik, you presented 4 very interesting use cases highlighting the importance of asymmetric split. But earlier on in your presentation, you mentioned the use of premium connectors that you also have by virtue of being vertically integrated. And I had noted that Glenn mentioned the move from splicing to connectors. And frankly, I've always felt sorry for the poor guy up on the pole splicing. And it did kind of astonish me that splicing in the field was used as extensively as it was. Maybe you could speak a little bit more, Erik, about the improvements in connectors that you've made. At the same time, you also mentioned one of your use cases was limited by having too many connectors. So clearly excess loss is still an issue perhaps with connectors, but could you talk a bit more about your premium connectors?
Yeah, so I think, like you mentioned, Karen, it needs to be both. So by being vertically integrated and focusing on quality and premium, we are often able to meet premium requirements, like the example that I gave for the customer that needed a 1x4 splitter with only 0.5 dB excess loss. But there's only so far that you can go. In this case, we were indeed just able to reach 6.5. But at 6.3 or 6.1, something's got to give because it's not doable. And that's, of course, when we arrived at the conclusion that the asymmetric splitters that were initially intended mainly for allowing a different architecture, the daisy chain or the tap architecture, or for the MDUs, that it actually can be used also to overcome these losses. So yeah, say a 7 dB loss for a 1x4 would be well available and cheaper. A 6.5 dB we can do, having all the capabilities that we have. But even if you have a few more connectors and the loss, required loss would be 6.3 dB, then it's not doable anymore. And that brings you then to the fact that you say, well, but not all of these four have the same power budget. Not all of these. So if you do it slightly asymmetric and only give the power to the user that truly needs it, you can also make the link budget work.
Very good. Also, another point that I noted in common between both Glenn and Erik's talk is the mention of, in Glenn's case, I think it was implicit, of reliability. Erik, you mentioned that explicitly, but Glenn, you certainly alluded to this idea that the passive network is well suited to being out there through multiple generations of upgrades on the active side. What kind of reliability are you guys targeting, both of you? And are there any cases of any unusual, perhaps geographic diversity driven reliability requirements that are particularly demanding? Extreme temperatures, I don't know. Erik mentioned it's better for infrastructure to be buried, but I don't know, with earthquakes, does that change things? Maybe you could talk a little bit more about these kind of reliability considerations when we're talking about this kind of network, which is quite different, frankly, from any other infrastructure, non-infrastructure type, equipment requirements.
Yeah, I don't know, Glenn, if you want to talk to this, but shall we say, at least from my perspective, I think that the PON network has been an enormous improvement over the copper network with many more components that could fail. And at least on our end, it's not just the reliability of the PLC splitter per se, but it goes all together. It's also shipping on time. It's also support. It's the entire end user experience. But specifically for the components, it's important to note that actually there's some carriers that really can do all of the shake and bake themselves, but there are newer carriers that may not always have these testing capabilities. And for them, it's important to really be able to rely on their supplier.
Yeah, agreed. And Karen, I would say the only thing I would add is that while that we talked about a lot more aerial in rural, that's a great thing for trying to find the cable and being able to place it quicker and cheaper and connectorize it, everything to that nature. But it's also more vulnerable, to weather or any type of things that you might imagine, trees falling on them and things of that nature, ice storms and things of this, that it's natural disaster stuff, I guess. But good thing that it's aerial, goes up quicker, goes up cheaper. It's easier to find, and where the fault is, you don't have to worry about somebody driving a pile line through it, but they do hit it with trucks and trees and anything you can about imagine that you find out in a field. So I would say that's the one thing that gets you. Other than that, it's fiber, and it's going to last a whole lot longer than the copper did, and you don't have the same maintenance issues that you had with copper from a water penetration or anything of these natures, kind of a inductance or anything else that might affect your copper plant. Your fiber plant is very much superior.
I do have a question from the audience, if it's okay. And Erik, it looks like this is for you. The question is, can the PLC be used with any technology, and specifically XG-PON and 25G PON?
Yeah, okay, well, thank you for that question. So of course, in all versions of the PON, whether BPON, GPON, XGS-PON, the NG-PON2, they all rely on splitters. And to a good degree, that's all PLC splitter based. And to a good degree, this is all indeed the 1x16, the 1x32. So the splitters are really across all the different standards and different architectures. And I think what is important here is that indeed you work with somebody who can support you across the board, because in practice, you may need asymmetric ones, you may need different splitter sizes, but it's important to be supported across the entire range of different components. But one thing that I wanted to add is that, which I would say for these use cases, if indeed there's somebody in the audience that is in a situation like that, where the link budget is not enough, they've been trying to get components with lower losses in order to fix that, then definitely reach out to us. You see all the contact information in here, and then we can gladly help you by running some calculations and showing how much power could be saved.
Well, thank you very much, Eric, and thank you for the questions from the audience, and Karen and Glenn. It's time we need to move on, and I couldn't but help thinking about operational issues when I listened both to Glenn and Eric's presentation. And so it's quite appropriate that our next presenter, who's Johan Hjalmarsson, who has been working with OSS BSS for almost 20 years. And Johan now works with NetAdmin, and he's going to talk about what should you consider when choosing an OSS BSS for your fiber business. And so this is a nice transition from what we've heard so far. So Johan, the floor is yours.
Thank you so much, Daryl. Good morning, good day, and good evening, everyone. So I'm Johan Hjalmarsson from NetAdmin Systems. And today I would like to talk about what to consider when choosing an OSS BSS for your fiber business. So been working with OSS BSS for almost 20 years now, and I'm really excited to share some of my knowledge with you based on the experience from various fiber rollouts in several countries across Europe and as well as worldwide. Firstly, I would like to emphasize the importance of OSS BSS in the fiber industry. So my experience is that high quality and well-suited system landscapes, including OSS BSS, can really increase the rollout pace and the value of a fiber network, as well as, of course, improving customer experience and loyalty. So I've, during the years, seen many examples of operators that successfully utilized OSS BSS software in their organization. And this is what I would like to talk about today. However, I have also witnessed the negative effects when operators don't have the right OSS BSS software in place. And to illustrate this, I listed some of the obstacles that can arise when you're using inadequate OSS BSS tools to manage your rollout. And these include, availability check problems resulting in loss of sales opportunities. Could be poor address quality that leads to number of issues with customers as well as with service providers. And then you could have installation errors due to the lack of verification. You could have long order lead times and failure in the order process. Manual processes that would increase human errors and put workload on your staff, as well as incorrect billing that results in customer complaints and bad customer experience. Or inefficient campaign management that would increase cost and workload. Or difficulties launching new products and services, making it quite hard to front competition in the market. All of these obstacles can distract you from the core objective of rolling out the fiber network. However, by investing in proper OSS, BSS from the start, you could avoid several of these obstacles and focus on what really matters. So, what is the solution to these obstacles beyond simply having a good and purpose-built OSS, BSS software? I would like to emphasize 3 high-level considerations that the software must meet to ensure a successful fiber network rollout. First of all, correct data model that can represent your business. And of course, data quality, so that all the automated processes that you implement runs smoothly. And 2, robust and well-defined processes. And that is to minimize human errors and increase operational efficiency. And the last one, automation and self-service that has the potential at least to lower cost, workload, and avoiding human errors. And I will go through each of these considerations in more detail. So first, correct data model and data quality are paramount to being able to answer your customer's inquiry about service availability and to handle orders correctly. High quality address data is essential, and you must integrate it with your customer portals and other BSS systems. If you're working with wholesale, service providers, external service providers, will heavily depend on you having correct address data available. The address or location of the customer, that's really a key asset that remains in a fiber network. Therefore, it's really important that the system you choose is sort of address-centric. If you compare to older OSS systems, they may center around a telephone number, or in the case of cable, you center around the cable modem MAC address or something. Or in the case of CRM, the system is centered around the customer. But in the case of fiber, the address gets really important. And it's really important to track the address build-out status and its connections to technical infrastructure, customers, subscriptions, tickets, work orders, and much more. And also, I would like to say that you need to watch out for highly generic IT systems, because such systems can be costly and complex to customize for the fiber business use case. They are often not really able to represent the fiber business without a lot of customizations. There's a risk that the level of customization needed will bring you quite large costs in the long run. If you choose to go for such system in combination with OSS, for example, designed for fiber network management, then make sure that you identify the customizations and the integrations needed at an early stage, so that no unforeseen costs occur later. Aligning with standards can also be important sometimes. For example, for a fulfillment stack, it can be useful to align with TM Forum Open API standards for the integrations northbound. For example, service ordering API and product ordering API, or aligning with the SID data model for how to model your data. OSS BSS systems have been used for many years. They have a sort of data model that has evolved over time to meet business demands. The work and effort to create that data model is often hidden at the first glance, but when putting these systems in operation, it will be obvious what the value is of a proper data model in operation. Secondly, you need to make sure that the software has robust processes. Robust processes are crucial, including availability, installation, order to cash, trouble to resolve, proactive maintenance, and the extra functions and processes that are needed to handle a wholesale business model. These processes need to be built into the software in order to avoid human errors. And here availability refers to the ability to tell your customers which products and services they can get on a specific address, to what cost and when. And installation refers to verifying that an installation has been carried out successfully with all the logging and technical information stored. Order to cash refers to having a fully automated onboarding and service activation process that would more or less cover everything from product offering to order, installation, activation, and billing, together with all the necessary communications that needs to be sent out to either customers, field technicians, and other parties. And trouble to resolve refers to help desk technicians being able to troubleshoot the customer using easily accessible technical tools without any help from second line support. Proactive maintenance refers to the tools needed to determine if you're running out of ports or capacity and things like that. Finally, you need the extra functions and processes that are needed to handle wholesale business model, including tools that the external service providers can use to onboard as well as serve their own customers. And third, you need to make sure that the software can automate your business. Since margins are quite low, it's really necessary to focus on volume. And with volume comes a lot of workload. Therefore, it's essential to automate your business using self-service and automatic activation without any manual processes. And in the case of wholesale, where the margins are even lower, it is even more important to automate and create a sort of self-playing piano where the service providers and the customers does all the work on their own. Also, I would like you to think about a sort of automation roadmap. So the level of automation needed will vary depending on your subscriber volume. So if you have small volumes of subscribers, it doesn't really make sense to automate everything. But when you grow, even the smallest little thing or process can add up a lot of workload for your staff. And therefore, it's important to plan and to create an automation journey or automation plan. So do you want to onboard customers zero touch using self-service? Do you want to have all communications automated based on events? And should the billing process be fully automated? What should happen when customers don't pay their bill, for example? And what about the other processes like move and deactivation and upgrades of their services? As your customer base grows, it becomes increasingly important to have the right troubleshooting tools available to ensure customer experience as well as loyalty. Support for common network vendors is also beneficial, as it allows for a tight integration between OSS and network elements, so that you could utilize all the cool features to achieve even more automation, such as automatic detection of ONTs in a GPON network or understanding the customer impact of a network event. It is also very important that the network status is transparent to all parties, even the customer in some way. You must be able to provide information on how the network is performing. Otherwise, you would more or less leave people in the dark, and you will get dependent on scarce technical resources. And this is also very important in a sort of wholesale or open access scenario. So the service providers, they need to have all the necessary technical tools available in order to serve the customers. Otherwise, they will more or less overload your staff with tickets. So to run into the conclusion, investing in a proper OSS BSS from the start is crucial for building a successful fiber network. So let your organization grow into the OSS BSS software by using an automation roadmap, and make sure that the chosen system can cope with that roadmap as well. And avoid all the obstacles in your fiber network rollout by following the 3 high-level considerations that I have emphasized today. And by doing just that, you will gain valuable time, and you can focus on your rollout rather than focusing on issues. And with a high build-out pace in your fiber network rollout, your business will be worth much more. Thank you for listening.
Yeah, thank you, Johan. Very, very nice, very interesting. It gives me room to start to think. Particularly interested in the comment when you were talking about the data model, and you focused on the address centricity needed for fiber as opposed to other networks, whether it's copper for telephone or data networks. Why is that? It struck me. I thought, well, why is that the case? Why is that so unique or so important in this particular scenario?
I mean, in a fiber network, I mean, the address, it's really one of the most important objects, and it has a sort of life cycle. I mean, it's you start with it being planned, and then you get an order for installation, and it's installing. You're activating that address. And then you get orders on that address, and you get customers. I mean, the customers aren't really on the network before you have planned the network in some sense. And then it's operational, and you get issues and so on. And at some stage, I mean, to be frank, customers, they come and they go, but the address will always remain in a fiber network. So it's a very important object, and you need to manage it properly, I would say.
Yeah. Are there any questions from the audience?
I do not see questions from the audience right now, but I actually wanted to follow up myself on this address question. So it sounds like you're saying the complexity of fiber versus some other utility is that there's this massive rollout, which
Yeah.
you know, we're no longer doing massive rollout of, say, plumbing, for example. But nonetheless, the address strikes me as something that is much more general than this fiber network. Is there anything in the way of synergies with address data for other utilities, government services? You know, is there standardization? You mentioned TM Forum, but is there standardization cross industries for things like address?
And one that comes to mind is emergency services. I mean, it's quite critical, right? That that folks still use a landline. If they don't have a cell phone, they're not going to get automatic
Yeah.
geospatial data, that it's going to be based on where that landline's at, or where that broadband service is anchored at that
Yeah.
address. And
I mean, we see that all the time. When a fiber market matures, we often end up having fiber operators synchronize their address data with numbers of sources. That could be governmental institutions, it could be different register, postcode register databases with the post, and so they are cleaning their address data all the time, a continuous process of getting the data quality up so that they can minimize a lot of issues in their business.
Yeah, that's interesting, but it isn't just a one and done, but it's a continual process that they have to keep on top of. And then at the other end, I guess, then the operator's data has to also align to their wholesale customers, right? And who may have their own data structures, or would there be some effort to standardize that so that the fields are aligned, you know, from the get-go, that they don't have incompatible support systems, say, between the two service providers?
Exactly. Much can be said about that, but I mean, you add another layer in between the subscriber and the wholesale operator, and with that comes a lot of complexity. And it is a little bit tricky to start with wholesale if you haven't done it before. But on the other hand, it's actually much more simpler than doing a retail business. But you need to focus more on automation. You need to have more. Even more, I mean, you want the service providers to serve the customer fully, and you need to provide the tools for them to do that.
Do you have an example of, you mentioned troubleshooting tools that would enable further automation? You know, are there things that you can point to where, you know, either you've seen a big improvement in tools enabling automation, or critical areas where you would like to see more things that would enable better automation at the OSSBS's level?
Yeah. Traditionally, you have a set of tools that you would run to understand the status of a customer. And often you do that one by one, and you have some sort of knowledge. I would like to it would be much more nicer if there would be some sort of flow thinking in all of that, so that you're running through a lot of tests and that could determine whether the customer is okay or not. And of course, provide that to the customer as well as to service providers and internal help desk. So a more flow thinking in that sense when it comes to
Instead of you take
troubleshooting.
it one step at a time, and then
Yeah.
the service person has to say, oh, that didn't work, let me try the next test. That it would just sort of automatically run some suite of tests. Yeah.
And of course, you can go into the proactive side of things. So understanding when there would probably be customers phoning in, and you need to mark those customers and being more proactive, of course, sending out messages saying that we're onto this and so on. Much can be done in that space, I would say, for fiber operators today.
Interesting. To use Erik's car analogy, you know, it's like the service light comes on in your car before the car breaks down at the side of the road.
Exactly. The mechanic could already be there serving your car.
I like that idea.
Yeah. Would be handy when talking about the Saab, right?
But as I listened to Erik's presentation and the asymmetry that he described, I wondered if that present operational or challenges from a network management perspective. I don't know, Johan, if you as you were thinking through that or looking at that and thinking that, does it lead to anything that's that might be a challenge because it's different? It appears to be different.
Can I say something?
Yeah. Oh, yeah,
there?
yes.
That's
Yeah.
okay. I mean, I think that's an excellent point, and we've heard that from customers as well. Because right now, if you would have a 1x64 splitter, you know, the 64 fibers are all identical, so it doesn't matter. You don't need to keep track of which fiber is going where. Once you start to, I mean, I would think that you cannot afford to really throw away the power in the way that we were able to do with earlier generations. So you need to be power conserving to a good degree, but it will lead to, you know, carriers having to be more mindful as to which fiber is going where, because now not all of those fibers will be identical. But I would think, but of course, Glenn and Johan may be able to say much more about that. If we think about the long haul, the metro where we have individual wavelengths, you need to keep track of the fibers anyway, because they need to go into the right port of the WDM. So I would think that those capabilities are there, but yeah, indeed, there needs to be a way of tracking which fiber goes where.
Yeah. Well, it's an interesting comment, Eric. Thank you, because it in fact it starts to kind of morph into the next presentation. So, Johan, I thank you very much for your presentation. I found that very enlightening and very well done. So, thank you. Our fourth presentation of the day comes from Andrea DiGiglio. Andrea DiGiglio. Andrea is at Telecom Italia Lab, and he's been studying and doing research on the qualification in the field of telecommunications and information technology, and specifically looking at internet security. And so he's going to give us an interesting perspective, focusing on the evolution of long-haul optical network decision support systems adopting AI and ML. Andrea, the floor is yours.
Okay, you're still on mute, Andrea. I don't know if you realize. Okay.
Okay. Now it's a presentation that is different from the one that provided by my colleagues, because they essentially spoke about the access network with the PON, and now the something new with comparison with the other part of the webinar is that now we are dealing with the long-haul optical networks and the decision that is supported by the artificial intelligence. So what we are talking is, which is the concept of support system. The support system is the title of this webinar. So we consider now which is our declination for the support system. Then we presented which are the concept of disaggregation network, and then two applications of machine learning and artificial intelligence to the decision to be taken by the support system, the OSS, that is the estimation of quality of transmission, and the classification of attack. So, starting with the support system in Telecom Italia, when I was enrolled in Telecom Italia 20 years ago, something more, there are essentially, I worked on circuits, the SDH SONET circuits, and the circuits may be up or down. If down or not completely down, these are the error seconds and so on. So okay, if up the circuits can carry the traffic that for customer, if down, there is no possible to carry anything. And now there is a more complex situation where there are slices where the packets, the retransmission, different throughput, different delay, jitter, and so on. So the situation is more complex, and what is important is the quality of the transmissions, so the quality that is perceived by the customer. So if a customer don't for his or her application doesn't need the quality of transmission of a circuit, the throughput, and so on, perhaps that he is can be happy with the situation. Otherwise, if the situation is very challenging, the problem is that the quality of transmission is insufficient, even if perhaps the throughput of the delay is very challenging. So what is important? That we have to change the approach from a network-centric approach to monitoring what is perceived by the customers. The main advantage is that possible degradations of the service are discovered from the very first symptoms, and perhaps we can fix before the customer can realize that there is a problem. And when there is a network failures or an hacker attack, the visibility of the actual impact on the service can guide intervention priorities. In many cases, allowing failures to be repaired because the effects are perceived. The second concept is the disaggregation network. What is the disaggregation network in our long-haul backbone transport network? The disaggregation network means that we have hardware, transponders, ROADM, amplifier, and the software as independent pieces of equipment coming from different suppliers, and they are interoperating by API. There are many advantages of these, that of course the cost that some medium large vendor operators like TIM is not dependent of one or two suppliers, and these are the main advantages. The second advantage is an important advantage is the uniformity of network management. This is important for our presentation, because when we have a standard network management, it is easy to install third-party software or also a self-made software that help the control of the network and talk with the real control of the network. Now, when so this is the problems. The problems are, we have to set up a circuit, a long-haul circuits. To set up, to design a light path, a long-haul light path, we have precise formulas. Professor Poggiolini from Polito provides very interesting articles 10, 15 years ago about precise formula to estimate the bit error rate and the signal to noise ratio for a certain circuit. But there are some uncertainty. In particular, the uncertainty are the aging margin, the network loading, time varying penalties, and other parts of something that we don't know very well. So the only solution when design the network is that design a light path, is to put some 3-4 even 10 dB margins. So we consider that as the light path is longer 10-15 kilometers more. This is a problem because perhaps we can put a regenerator where the regenerator is not necessary, and to face all. So there is a cost for this. Nowadays, there are some groups. The most important is the group of Massimo Tornatore that is working out to integrate the artificial intelligence for estimation of quality of transmission and the routing of spectrum assignment together in order to reduce as much as possible this margin, and of course reducing as much as possible the total cost of ownership of a long-haul network. Now we are working on the same problems, but with different flavor. So from a real network, the network of Telecom Italia, we are connecting data. That this connection started in 2002 and finished some months ago. And the objective is to estimate the signal to noise ratio, to integrate with zero-touch automation for automatic setup of circuit, and the accurate attack classification. The steps are, of course, what is, and the engine of this is a machine learning, engine. What we are doing, so we are collecting data now. Then we are setting the algorithm based on random forest neural network. We consider supervised network, and we train the supervised network. Of course, even if we have a lot of data, we're realizing that the data are not strong enough for an efficient training model. So there is a process that is also considered in literature to augment the data. A final analysis of accuracy of data is done, and we consider a training machine. So we consider 27 KPIs we selected in a sliding windows of 90 days with a granularity of 50 minutes. As I said, we augmented the data, we select the data, so there is something that is not wrong. And we estimate, starting from the light path where we know everything of the light path, including the bit error rate prefect. We consider a training, we train a machine learning network in order to estimate the bear prefect for the new light path. The result is not completely satisfactory, but we think that we are in the right way, because what we consider is about relative error, squared error, 14%. That is something that is comparable now with the 10 dB of network cable margin. If for shorter links is something more. Okay. Stop with this, and now with another problem. So this is the problem of optical network security. A lot of articles starting on 2013 says that there is a problem. There are more or less three main problems. The eavesdrop that is solved by cryptography, the main on the middle. Now with the quantum key distribution, this is more or less solved. The problem is the denial of service that we don't know exactly how to solve in an efficient way. So there are some problems that we saw everything in our network. So we have thousands of kilometers of cable in external plants. junctions on 2-3 kilometers. So there are something that can bending the fiber, try to extract information or to insert insert light in the fiber to create the denial of service. The situation is that we provide in the lab an experiment where we consider 400, something more than 406 kilometers optical light system with 6 amplifiers to simulate what's happened, and we provide some KPIs. The problems, we consider 3 types of hacker attacks. One is out of band attack, so we insert a channel not in the band of the information channel, or we consider in-band attack, that we insert a channel, a fake channel inside the bandwidth of the information channel, or the polarization attack. That is something that is piezoelectric situation. We consider a rotation of the polarization of the coherence. All of these experiments are provided in Telecom Italia premises with the collaboration with Chalmers School of Göteborg. The situation is that for each of these types of attack, we consider a light situation and a strong situation. The idea is first to classify with a trained machine learning the attack. The results were very, very, very impressive. That we consider that using the multi-class decision forest, the attack, these 6 attacks, 0 is the baseline, the other 6 are the attack out of band light, out of band strong, in band light strong, etc., etc., are with the precision of the worst case is less than 3%, so is impressive. So what is the future? The future is that we have the OSS. We can consider with this northbound interface something that can be self-made or made by the software that is fed by the artificial intelligence results in order to help the decision for the maintenance, for phase of default, for classification of hacker attack, to the entire management of the network. I'm speaking about the backbone network, even if the main concept can be also considered for the network, shorter network, and sometimes for the access network. Grazie, that is thank you in Italian.
Thank you very much, Andrea. That was very, very enlightening. I have lots of questions, but I think I'm going to wait and see if there's any questions for the audience, or Karen, thoughts, comments.
Yeah, no, this is definitely very encouraging. You know, as you say, so I see both a common theme with the previous talks and something that's quite different and forward-looking. I guess the common theme first is you talk about the effort to reduce the margin, because this is an inefficiency which we used to be able to just live with, and in common with both, I think, Glenn and Erik and Johan's talk, you know, we're no longer comfortable living with this sort of wasteful network resource. And it looks like the idea is, if you could predict the margin or the consumption of the margin more accurately, then you wouldn't need so much. I guess, you know, you mentioned 4 different types of of margin leading up to as much as 10 dB, which is, clearly a lot. But which ones of these do you think from the data collection you could minimize? I mean, aging margin would still need to be there, or, is it mostly the time varying penalties and mostly the uncertainties that you?
Yeah. The main margin that you can reduce during the design is this one that I circled in red, because, for instance, the aging margin is not possible to predict, because it's something that in 3 years, 4 years, 10 years, and an optical system for long haul can last also 20 years. But there is a collateral advantages that the design provided by the artificial intelligence is also very fast, because once trained, a neural network is just operations from multiply and addition. So it's very fast to converge. Okay, we can also design the light path without any margin. And then if the margin occurs, the problems occurs due to aging problems, you can in less than 1 second tear down the circuit and set up another one that is new. Something that 10 years ago it's necessary 3-4 months to do this. So this automatic process can reduce also the margin, can reduce also the resources that you consider for the protection, because you are very fast to react and very fast to set up a new circuit, of course, if you have resources.
Yeah, Daryl, you had questions, so do you want to?
Well, I noticed Glenn turned his mic on, so I thought he had a comment.
Yeah, the only comment I'd make is that what we do with that excess margin, because all paths are not, especially in ULH, you've got, different A to Z locations, and the paths are usually different. What we do for anytime we have excess margins, we increase.
Sorry, Glenn, can you speak a bit louder, because
Yeah, we use that excess margin to increase the bit rate, given the modern transponders, the coherent transmitter receivers, and a lot of DSP that's available to us. So most of our ULH routes today, or the minimum rate is 400 gig across the entire country on our ULH network, but most of those paths today are turned up at 500 or 600 or 700 bits per second in that same spectrum, using that same transmitter receiver. But that's how we use up that excess margin, because you're right. I think my talk was waste not, want not at OFC 2 years ago or so. It was, why leave that on the table when it can be used for additional capacity? And then you put a 400 gig channel on there, and you fill the rest up with 100 gig channels that we have lots of, and you take advantage of that margin to get you additional capacity at the same cost.
Yeah, I agree. Essentially agree.
Yeah, what struck me, or perhaps I didn't understand, was the margins that we're talking about here being separate from security concerns, right? So all these 2 separate problems that are being addressed. So I think your next to last slide I showed, it suggested that no, this yes, this one, right. Okay, so so they're basically 2 different processes or analyses that's going on simultaneously. One looking at security issues, and the other one looking at this proactive fault detection module, or analyzing the evolution of the network over time and making sure that it's being utilized as efficiently as possible. Is that correct? Is my understanding correct?
Yes, is completely correct. Yes, there are. You can also add something that you can consider here. For instance, something for the energy efficiency. Something that the design of the network and the control of the network can also be considered externally with something. Now we consider also the artificial intelligence, but it's not necessary. The main concept is that we open the network, the control of the network from the proprietary OSS to something that is disaggregated in the hardware and software, and then the part of the software for the control is open and can be standard, more than open standard, and so everybody can provide some apps to feed the control.
Yeah. Okay.
So Andrea, I know you have to go very soon, but one last question for you, maybe.
Yeah.
You mentioned being open to third-party providers of apps, but at the same time you talk about fixing a network performance problem before the customer notices. So that struck me as subtly different from what Johan proposed, which is that the visibility of the health of the network should be visible to the customer. You know, they both sound like good ideas, but they are in fact a little bit different. So I wondered if you could comment on how you think about that.
My opinion is not completely different for Johan say, because the visibility to the customer is not necessarily the visibility of the customer. It's important that you know which are the applications from the applications, no, the need of the customers, and what are if your network is able to satisfy these KPIs. To do this, a way to do this, maybe, okay, I buy everything from Cisco, from Nokia, from Ericsson, and they provide all the control, all the stratum of the network, the hardware, the control, the management, and so on. The other way is that this piece of equipment are spread by different vendors, and there is a standards, and across some API, I can interoperate this piece of equipment with the standard software. This standard software can be enriched by applications that can be also tailored for the single network carrier, the single also the single customer of the network carrier. So that when a network carrier is Telecom Italia, that is big but not big and as Verizon, as Glenn, when we are talking with the big vendors like Nokia, like customer, we have a strong delay having some personalization. So this is something that can help also this. And we can also use some apps to increase the competition and have some advantages with the competitors that now is based also in OSS, as I think Jonas took on the site.
Yeah.
Johan, did you want to comment, Johan?
No, that's I totally agree. I think from a customer side of things, they need to understand things like if there is a problem with their local CPE, or whether you have a someone has dug off the fiber at some location, or you have a power outage or things like that. So really failures, total failures of the service in some sense. So, and that you need to be sort of transparent to the customer, inform them in any way possible.
Mhm, mhm. I see we're running up on the hour here. I'm wondering, do we have time for our final question?
I think maybe we should wrap it up at this point, given.
Yeah, I
the-
think we should wrap it up. I think we've had really good
Yeah.
conversation. I thank everyone, Eric, Johan, Andrea, Glenn. Thank you very
you.
much. I think,
Thank you.
This has been enlightening. Emma, can you put up the last slide, please? And just to remind everyone that this is an Optical Connections webinar. There's some events coming up. This will be, the webinar has been recorded, will be available for on-demand viewing from June 28th. That's a week from today. And there are two upcoming events, ECOC, that's going to be in Glasgow, that's in October. And hopefully I'll see you there. And then there's Telecommunications, Optics, and Photonics Conference 2024, that's in February in London. With that, it's 10:01, at least on the East Coast of the United States. Thank everyone for your participation, and this has been quite good. Thank you.